Good afternoon. So I'm Nigel Banks, Technical Director, leading on zero bills and low carbon homes at Octopus Energy. And in this ProCon webinar, I'm going to kick off by talking around how we can decarbonize our homes and reduce energy bills, even down to a guaranteed zero energy bill, in potentially a much smarter way. Um, and I'll start with where I probably was 10, 15 years ago in building homes with a very much fabric first mentality, delivering some of the first passive house homes, delivering some of the best performing retrofits, um, and still absolutely see the benefit of improving fabric. But one of the things that's really changed my mindset in the last few years is understanding what's changing in the world of energy. And maybe there is a smarter way to decarbonize our homes and reduce our bills that is more cost effective, is more scalable, and can deliver what we need to deliver as fast as we need to deliver it. And that really is part of the ethos of Octopus Energy, is using technology to drive the green energy revolution around the world, but do that in a way that makes it cheaper and faster for people as well as for the planet. And that is something which everyone at Octopus is really passionate about achieving. And we've obviously made great strides as a business and are doing some amazing things. But what we need to do now is really scale it up across the country and around the world. And hopefully talk you through some of the things that we're doing that are quite exciting that you can get involved with. But I want to start with a typical UK home's energy bill, and 60% of the energy used in a home is on heating, around 20% on electricity, and about 20% on gas. And therefore, a lot of people will look at that chart and say the biggest priority for reducing emissions, reducing bills, is reducing that gas consumption. But when you turn that into pound notes, because electricity is currently about 4 times the price of gas, electricity is more than half a typical UK household's energy bill, and gas heating is only about a third. So actually reducing that gas heating by half or even more is only likely to reduce your bills by about 15%. And actually there's other things now which can make a big difference. And in a new home, the heating is already lower because they've got better insulation standards. And actually that electricity consumption can be, or electricity part of the bill can be almost 60% of your bill, and heating down at sort of 20%. And you see that when we look at actual bills within the Octopus Energy customer base and by EPC rating. So this is the last, well, up until 2023, 5 years worth of bill data. And you can see the higher insulation standards, EPC A, B homes have got lower bills than EF rated homes, but not as much as many people would perceive. And that's largely because the electricity consumption and the hot water consumption on average is very similar across those properties, irrespective of the thermal performance that's reflected in the EPC. And it is possible, you can just about see a pink dot on the bottom right hand side there, to get bills down to zero. The other thing which has really been transformational in certainly the last 5 years and even in the last year, is the reduction in cost of some of the key bits of equipment that you may be specifying or thinking about specifying in a retrofit or in a new home. And solar panels is probably the most dramatic of those. I remember fitting 200-watt solar panels that cost us over £250 per panel. And we are now able to buy panels that deliver more than twice the output for a fifth of the cost. So a more than 10 times reduction in overall cost per watt of power. So the value that you now get from and the benefit that brings is significant. And at the same time, the cost of other measures has gone up when the cost of solar has really massively tumbled. The other thing which has really happened at quite a rapid pace in the last 10 years is the electricity grid has decarbonised. So this shows the last 70 years of the carbon intensity of the electricity grid, which is the black line, and a red line shows what the carbon intensity of direct electrical heating would be. The blue bar, what a gas boiler would be, and the carbon intensity of heating with a heat pump in the green bar. And you can see that since the 1990s, heating with a heat pump has been lower carbon than a gas boiler. And even now, heating with direct electrical heating, whether that be radiant heating or storage heaters or something similar, is actually lower carbon than heating with a gas boiler. The other thing which we are at a turning point is with the grid is, yes, we've turned off a lot of coal in our grid, and our remaining fossil fuels are likely to reduce significantly over the next few years, but we're also going to start rapidly increasing the amount of electricity used uh, through heat pumps and electric vehicles, but also rapidly increase the amount of wind power, particularly offshore wind power, that is projected to hit our grid. So this is the national grid's scenario that actually doesn't meet any of our climate objectives. They've got much more positive ones. This is kind of a worst case scenario. And you can see we've moved from sort of 10% renewable intermittent sources 10 years ago to about 40% last year. But in 10 years' time, we're up at sort of 70% variable renewable energy. And that means the cost of energy to the grid varies massively through the day now, much more than it used to. And over the last month, you can, this is actually the last month, but it's over a month. I think it's September, October time. You can see the price of electricity on the wholesale market, which we reflect in one of our tariffs called Octopus Agile, varies from being negatively priced. So we pay our customers to use energy at that times because the electricity market has got too much power, and it's actually cheaper to pay people to use energy than it is to pay to turn off wind farms. And whereas almost every day between 4 and 7 in the evening, when everyone's getting home and cooking their dinner, the cost of energy surges as we're turning on, up until last year, coal plants, but now gas peaker plants, and the cost of energy is very high. So what we tend to see now is when it's windy and then when it's sunny and there's low demand, the price is extremely low. So we've got low carbon, so we've got available low carbon, cheap or even free energy. But also at times of day, we've got very expensive energy, which is also highest, often when it's highest carbon. So there's a real opportunity to make big reductions on your energy costs and your carbon emissions by considering when you use your energy. But what most people see is that pink line across the middle, which is a typical SVT or standard variable tariff, which is set at the price cap, currently between sort of 20 and 25 pence a kilowatt hour for electricity. But as you can see, if you were able to shift when you use your energy, you could access much cheaper energy. So the agile tariff actually directly reflects the day ahead price in the grid. It's the wholesale price that energy suppliers can buy and sell at. And what we've done at Octopus is look at different ways of offering that in a simpler way to customers that makes the use of those cheaper times in a much simpler way for the end consumer. And I think it's worth just considering that reducing demand makes sense, improving efficiency through efficiencies of heat pumps makes a lot of sense. But the third factor in your running cost is your energy tariff. And one of the best ways of understanding this is looking at an electric car versus a petrol car and where and how you charge that. So if you were driving 10,000 miles a year and you were filling up a petrol car that is 50 miles a gallon at £1.40, it would cost you over £1,200 a year to fill up that car. If you had a reasonably efficient electric car doing 4 miles per kilowatt hour on this is probably a little bit out of date, but on a tariff of 21.2p, so a standard flat rate tariff, you're looking at 500 or maybe £600 on current today's tariffs. Whereas using our Intelligent Octopus Go tariff, which smart controls when the car is charged, so you get home, you plug your car in, and then the Octopus app will tell you a schedule when we'll charge the car, and we'll have it charged to whatever level you want it by whatever time you want it. But we'll charge it in an intelligent way and only charge you 7 pence a kilowatt hour because we can make use of those really cheap times or even negatively priced times overnight. And we can charge your car for potentially under £200 for 10,000 miles. So that really gives you a great example how moving to electrification can significantly reduce costs and electric vehicles being efficient. But also, if you can use smart tariffs, you can even further reduce and really get quite spectacular savings. And we've developed tariffs for lots of different devices now, so not just electric cars, but for batteries, for heat pumps, and we've also now got a new tariff, Intelligent Octopus Snug, which is for electric storage heaters. And the way we operate is we don't have a big device in the home that's a sort of home energy management system. We don't use them. We directly interface either with the car or the charger or with the battery or the heat pump controls through the customer's broadband or Wi-Fi, and so we very cost effectively integrate into those appliances and devices and offer tariffs that really work for them. So the EV tariff is cheap at night. The battery tariff is cheap at night and high price in the evening, but you also get a high price to export in the evening. And the cozy tariff has three dip prices where it's cheap to charge or run your heating in the morning, in the afternoon, and in the late evening as well. So you can make use of those cheap times in a simple way. And what we're now able to do is bring all of that together into one pretty unique capability and offering, which is to guarantee customers no energy bills for at least 10 years. This is a tariff which we launched about 18 months ago, and we combine a air source heat pump, typically, other form of electric heating, with a home energy battery, with solar panels on the roof, and we use our software to optimize when we import from the grid. So when we have got those negative prices or very low cost electricity, we'll fill up the battery in the winter, and we may run the hot water cycle and heat up the hot water cylinder. And then when we've got very high prices on the grid, we'll discharge that battery, which has either been charged from the solar panels or from the grid overnight. We can also use the battery and the heat pump to help stabilize the grid locally. And currently, large batteries get revenues from doing that. And we can aggregate up lots of home batteries and do the same thing. So we're able to offer eliminate energy bills by generating enough revenue from exports and grid services to offset the cost of imports and guarantee that to consumers on a long-term basis for at least 10 years now in new build. So we launched that a couple of years ago and have been really starting to scale up, and we're getting some really great traction now. We've assessed over 5,000 homes. There's about 1,200 sort of now committed in construction. Got 50 to I think nearly 100 homes occupied and coming online very quickly. Obviously, the development cycle of committing to a home 2 years ago, those homes are now starting to get built. And we've partnered with a really large number of house builders, build rent funds, housing associations, and local authorities to deliver across the country. And we've now recently launched in Scotland as well. And we're also live in Germany and New Zealand and looking to go into other countries with zero bills as well, where Octopus Energy is a retailer. So here's some of the brands you recognise that we've been working with on some of the early sites, and many of those homes are now built and occupied, and have been selling well. The experience we've had has been generally very positive. We have had some mixed experience, and that's generally where the sales and marketing of the zero bills home hasn't been great. But there's a couple of good examples I want to share where the developers are getting recovering the extra cost of installing the solar and battery systems and the heat pumps, and getting good sales rates as well. So this is the Hill Group site in Newport, Essex, where there's 89 homes. All of the homes are zero bills, from the bungalows to the large 5-bed detached that look over the field to the back, as well as the 25 shared ownership and affordable rent properties as well with Clary and Latimer. Another great scheme with Thacum is the Burgess Hill scheme. They've got down in Burgess Hill, which is the Templegate scheme. They've got 48 zero bills homes as part of around 100 home sites. They've got a mixture of zero carbon and zero bills homes on that site. And my understanding is that the zero bills homes have been outselling the zero carbon homes significantly by sort of a factor of 4 to 1. So seeing faster sales, and they are recovering their extra investment in the extra solar and battery system to enable them to get to zero bills. So hopefully that shows you how you can, through the introduction of some key technologies like solar panels that are now very cost effective, like home batteries that become very cost effective, combined with a good fabric performance and efficient heating system like a heat pump, you can get bills down to zero if they're smart controlled. And that's one of the reasons I've sort of shifted from that fabric first mentality to something I wrote last year, which caused a bit of contention, which was an article called Fabric Fifth. And as I say, there's a number of things have really changed in the last 10 years. We've got much lower carbon grid. We've got much cheaper batteries and solar panels. We've got much better performing heat pumps. And at the same time, the cost of insulation and the quality issues with some of the insulation has been significant. And looking forward, those trends are likely to continue. The grid is going to zero. So when you move to a heat pump or any form of electrical heat, you will decarbonize your home. Insulating your home does not decarbonize it if it's still using a gas boiler for heating and hot water. You need to move off that fossil fuel heating to do that. And excitingly, we're now looking to see how we can take that zero bills approach into retrofit, upgrading existing homes and seeing how we can get them to zero bills. So this, if you hadn't seen the Fabric Fifth, the sort of hierarchy that I suggested, which is quite different to the Fabric First, was this one where we had installing heat pumps with smart tariffs and smart meters with some basic measures initially. And then probably the most controversial is saying that a solar and storage system is probably a better way to reduce bills and probably have a similar impact on carbon emissions as deep fabric retrofits. It has been pointed out that it probably should have been renamed Fabric Third and Fifth, or Third and Fifth, because actually in that step 3 I'm suggesting basic measures. But I think there is an interesting piece there where a lot of people are saying, no, you must fit basic measures before hitting a heat pump. And interestingly, what we've found is many homes are heat pump ready as they are, and potentially would benefit from basic measures, whether that be topping up loft insulation, doing cavity wall insulation. And certainly, if you can do those things at the same time before, fantastic. But for some people, they just want a new heating system because their boiler's breaking or broken. And they didn't want to have to wait 3 months to upgrade to get the cavity walls insulated before fitting a heat pump. And one of the things we need to do is really accelerate the adoption of heat pumps. They are a fantastic technology that works very well, and with a smart tariff can deliver significant bill savings. If they're installed well and controlled well, with a good tariff, you can make significant bill savings today. But the one key measure that makes the biggest energy bill saving is solar and storage. You can massively reduce your energy bills, and to such a level where it is now financially advantageous to do so. You get better returns out of installing solar storage than you would do putting money in savings accounts. Whereas deep fabric measures, although can have a big impact on comfort, can have a big impact on health, are very expensive and don't deliver as big a reduction in bills or in carbon. So we're not saying don't do it, but what really drove this article was seeing tens of thousands of pounds are being spent and gas boilers being left in place, and no money being left to then upgrade the heating system. And that's why rethinking that hierarchy, and this chart tries to explain that. So on the left-hand chart, you've got cost of install along the bottom and carbon emissions in blue and bills in red up the left-hand side. With a typical fabric first approach, you may be spending upward of £40,000 doing a full fabric upgrade, but you may only be reducing your bills and your carbon emissions by 20-25%. Whereas taking the Fabric Fifth approach with heat pumps and then solar and storage for sort of £10,000-15,000, you can be massively, if not completely, eliminating the carbon emissions from your home and making massive reductions in your energy bills. And then if you have got additional funds to do the deeper retrofit, absolutely makes sense. But hopefully those two charts show the sort of different ways of operating, that there's a lowest cost, lowest carbon route to delivery. And that's why I think there is an interesting way to rethink how we decarbonise our homes and reduce bills, even down to zero, in a smarter way by focusing on the technologies that deliver the biggest impacts in the most cost-effective way, using technologies that are rapidly scalable, quick to install, and hopefully that has been insightful and creates some interesting thoughts and challenge. So happy to take questions in the Q&A, but I will pass on to Jason now.
Thanks, Nigel, for that introduction. Now we'll look at what is the latest information on the Future Home Standard and an overview of the home energy model, which is replacing SAP. So my name is Jason Redfern. I'm managing partner of Focus Consultants. We're a multidisciplinary construction consultancy practice which operates out of Nottingham but across the UK. I'm a chartered building surveyor with 25 years industry experience, predominantly having worked a lot of that time within the sustainability sphere, helping with decarbonisation strategies, compliance strategies for a range of clients across the UK, both local authorities, developers, contractors, and private individuals. Head office in Nottingham, but we also have an office in London and Leicester. And as I said, we have services certainly within the sustainability sphere, which are nationwide. So what I want to achieve today in terms of key takeaways is to provide people with the latest information on the Future Home Standards introduction, what we know from various sources, to provide an overview of the home energy model consultation, the replacement for SAP, and to provide what I see as the key impacts of home energy model's introduction to replace SAP. So just looking at the Future Home Standard and what we know now, from the information we have and have seen various communications, it looks as though we should expect feedback in March of this year. Now that could change, but that's the latest information we've seen from our numerous sources that we're expecting feedback on the Future Home Standard in March 25. Within that, we're expecting that option 1 from the Future Home Standard will be adopted. Now, option 1 was a fabric specification that we currently have for approved document L, a slight improvement. It required a heat pump for the main space heating source and domestic water, and it also encouraged a specific level of photovoltaics, PV generation on the property. I think feedback that we saw was the industry was slightly nervous about the variance of building type across the UK and the ability to fit PV to it so readily. So we are expecting a relaxation on that to be identified in the consultation, but we shall see. If the consultation response comes in March, we expect it to go before Parliament as a piece of legislation in June this year. And then we're also hopeful of receiving what will be a later version or the latest version of home energy model software. With that timeline, we would anticipate that what we would call, I guess, the Future Home Standard, or maybe the newer version of approved document Part L, will come into force from June 2026. And we anticipate a similar transition process as to last time. That is, you will have, if you submit your application before June 26, a 12-month transition period to make a meaningful start on site of your development. Anything that doesn't have a meaningful start on site will be subject to the new regulations post June 27. Equally, if you submit your building regulations application after June 26, you'll be subjected to the new regulations. So that's the timeline for what we know about Future Home Standards introduction. But HEM is obviously intrinsically linked to Future Home Standard, given it's the software for its delivery. So we're going to look at some of the background and context to the Future Home Standard and Home Energy Model consultation. The consultation for Home Energy Model was after FHS. It opened in December 23 and it closed in March 24. It will be the software to deliver the Future Home Standard. And as with the Future Home Standard, we await the feedback on the consultation, but we expect to get simultaneous responses. The Home Energy Model came about because the government in 2020 commissioned a study which identified a need for change, and specifically a need for SAP to change. It wasn't felt that it was fit for purpose. It was felt that the industry needed a tool that was better aligned with the UK's 2050 net zero aspiration, and it looked at the alignment that SAP provided for its strategic objectives at the time, and they didn't sync. It wanted to see improvements to the methodology. It wanted to see a broader use of the data from SAP in what it called its ecosystem for net zero. And it wanted much more accurate and better evaluation of energy use in SAP to more accurately understand demand in the UK, thus supporting decarbonisation of heat and electricity. So that was the need that was identified for change. And in 2021, because of that need, a consortium was set up, led by the BRE, and overseen by Etude for the development of what was SAP's replacement. SAP, by its nature, standard assessment procedure, the government suggested implies that it's a single application. And they didn't want to necessarily keep the name, because if we did, then it would be continuity with the previous versions. So SAP was proposed to be replaced with HEM. This HEM is a new model that is developed from scratch using alternative sources and research far and wide that the development team did for what is a more holistic tool with much greater potential for use across a broader set of applications. One of the most significant changes is in the delivery model. Currently, SAP software is software that's developed by a contractor. It's approved by the government through test cases, and it has been criticised, this process, for potential inconsistencies between the software packages available to the industry. It's also viewed as being slow to develop and doesn't really have any accountability. Therefore, this graphic shows to you what the government's aspiration is. It wants a simpler model. It wants the software to be very open source, so people can understand what's the mechanics behind HEM software. They want it freely available. And they want to do that so people within the industry can understand what HEM can generate, look at its outputs, and potentially look at some innovative additional modules, or what we'll call wrappers later on, that can support HEM and support the industry. This centralized cloud-based approach, as it's currently proposed to be, should provide consistency in results. It's a single source for the software. It is a government software, so it provides that accountability. It should be easier to create interfaces because of that open source software. And from that, as I said, drive innovation. But also it should, as a single source software, provide the ability to modify and update much swifter. Again, one of the major changes is a revised product database. So the current product database in SAP will not be compatible with HEM. So the development team sought to rebuild the database from the ground up. And this presented an opportunity to think about what can go into it, what the outputs would be, and actually, could it be more detailed in terms of the assessment of products going in there? So HEM does recognize, with its proposed database, more detailed performance characteristics of heating products, ventilation products, and so on. That, in the government's eyes, does present an opportunity, as with the previous slide, for innovation, for understanding what this database looks at, understanding what its outputs are, and perhaps products more, giving them a greater opportunity to tailor themselves for performance in HEM and performance for the industry. So hopefully driving innovation. Another area that the development team, and through the consultation, identified was the ability to get new technologies into the product database. From my own experience, that can be challenging. Having worked with many products within my 25 years of working in the industry, I've seen some of the barriers that have been faced in trying to get your products into SAP. There is kind of a lack of transparency in relation to that process. And for those individuals I've worked with, there is a financial burden associated with putting your product on that database. Not only is it the cost of submitting it for assessment, but it's also the program and time frame of that assessment, which can impact on your product delivery to market. Even when it goes through the process, the software cannot always accurately represent that particular product. Therefore, there is sometimes an Excel spreadsheet or supporting document that you have to fill in tandem with doing the SAP calculation. This was seen as being quite protracted and a barrier also to new technologies. So the new process is intending to be simplified, much more transparent to understand the process. It should be open, and the research and products on there should be shared across other government initiatives, such as eco-funding or past 2035 funding. This should hopefully encourage continuous evaluation. If you can see how your product performs in the database, you can look to see how you could develop it and evolve it to perform better within HEM software or other bolt-on modules or wrappers to HEM software. Ultimately, it still will maintain its integrity. It has to stay robust. It has to give the industry confidence on the performance of these products, because at its base, that's what HEM is trying to achieve, is more accuracy, more understanding, and better prediction of performance. So HEM will have a core engine, but it will utilize wrappers. And the wrappers are pieces of code that wrap around the core program. And one benefit of having wrappers is that it means that if there's any further development required to these outputs, they can be done independent to the core engine that underpins HEM. Wrappers can be user-centered in terms of design. So you can see here you have your standard inputs to create the notional dwelling, as it were, and you have the user inputs, what their U values are. But creating wrappers will provide clear outputs, and it also allows those independent updating to those wrappers and those outputs which don't impact on the core engine. It means that we should receive much simpler improvement and development of the software without the core engine being having to be disturbed. And as you can see here, wrappers will provide greater clarity and accountability with examples such as the Future Home Standard wrapper or the EPC wrapper shown on the graphic. Some of the step changes that HEM software will provide in relation to compared to SAP. Well, HEM will increase the time resolution quite considerably. So SAP at this moment in time assesses on a monthly basis. HEM will simulate the home or the building at a 30-minute time interval. Now, this gives benefits in relation to fewer constraints to analysis. It's not a monthly basis, it's every 30 minutes. You've got really minutiae of detail in terms of performance. It will also provide flexibility in terms of modeling different elements. At 30-minute time intervals, there might be variance. There may be other elements that are allowed to be at hourly intervals. But again, it's providing flexibility. This graphic talks about heat performance being more accurate, but ultimately all performance of all products in the home should be more accurate. And they're also modeled in the context of the home more accurately on that 30-minute time step basis. Clearly, smart technologies, products that improve the efficiency and management of the home's energy are going to benefit, because the 30-minute time step means that you can much more accurately understand energy use in the home, energy demand, energy generation, energy surplus. You can consider the tariffs actually during energy use in the home. So it provides much more benefits to smart technology deployment in the home. And overall, much more accurate energy use modeled for the home. HEM will have a modular architecture, which does provide ease of use with inputs. And again, it offers that clear ability to design and continuously develop the software, shown here with heat water storage or heat sources, separate modules that can be separate from the core engine, adjusted, developed, and tweaked without the overall core engine being unpicked. Another step change is energy flexibility, which kind of links to Nigel's presentation. And that's the ability to adapt and regulate energy use, generation, or storage in response to what we're seeing in the home or the wider energy system. Having this level of information empowers consumers to make choices. So with HEM, energy flexibility and choice is supported by that half-hour simulation. And HEM should allow, potentially through a wrapper, for profiles to be adjusted or occupancy profiles to be adjusted within the home. This permits much more realistic modeling of the interactions between the supply and the demand in the home. And clearly, it should identify benefits from storing, exporting, and load shifting, as well as the behavior of the occupants, which could be identified. Another area of change is solar PV and batteries. So energy generation and its demand is modeled in a clear set order, as set out in the consultation. And that's here on the right-hand side, showing you what the order of energy generated is allocated and the priority for meeting demand in the home. Now, the consultation said that this could be more flexible to account for time of use. So you could look at the benefit of import and export tariffs, as Nigel was going through. But also, solar PV performance will be much more accurate, with the system still based on location, orientation, and pitch, but shading will be taken into account much more accuracy. So you'll get much more and better understanding, again, with that 30-minute time step of what PV will be generating at what time of the day, depending on where the home is built in the UK. Electric batteries are obviously key to part of the UK's decarbonisation strategy, and they will be fully integrated into HEM software to understand their ability to store, to charge from the grid and to discharge, and generally support with the overall energy consumption within the home. Other notable changes, and there are many, but there isn't time to really go through them all. Well, thermal bridges and heat loss at junctions will benefit from the 30-minute time step. Again, much more accurate understanding of what's happening in the fabric of the home, how heat is filtrating through the fabric, and point thermal bridges will also be introduced and a requirement of HEM, not just linear bridges. Infiltration will be assessed utilising a variable divisor from City Guide A rather than a fixed division that we have now. A minimum ventilation rate, which is default currently in SAP, will now be user input from a wrapper, and MVHR will account for ductwork losses, which it currently doesn't do. Thermal mass used to be the first 3 layers of the first 100 mil. The whole element will now be accounted for. A building element, say a wall or a window or a floor, will be considered for its mass. And interestingly as well in HEM, furniture and potential for furniture in the home to add to thermal mass will be considered as well. The accuracy doesn't stop there. Solar gains will be much more accurately assessed in HEM software, with slower absorption from paint panels taken into account. As with photovoltaics, shading will be more accurate in HEM software, but it does currently exclude movable shutters, curtains, and blinds. Domestic water and its use will benefit, as with space heating and other elements, from the time step change to 30-minute intervals. And hot water cylinder and their entry into HEM software equally get another overhaul to ensure that their performance is more accurately represented. Following the non-domestic approach, heat losses from domestic hot water pipe work will also be modelled in HEM software, again to improve the accuracy of gains within the homes and losses. Okay, so we now move to the final thoughts in relation to the presentation. So I've covered, if we think about the key takeaways I wanted, I've covered what I think is the current Future Home Standard introduction timeline. Now that could be subject to change, but what I do know from working with my clients is that the industry is chasing an answer. People want to know what is coming from the Future Home Standard consultation output, so we need the answer as soon as we can do. Home energy model is a step change, and its intent to try and provide this holistic tool for all, I really believe in. I think that there should be one tool that unites them all, so I believe that and support what HEM is trying to achieve. It also looks that in tandem with Future Home Standard, it's helping to change how we model energy use in homes and provide more information to the people that build and develop homes, and hopefully through wrappers through existing homes, about energy choices, and help the UK achieve its decarbonisation aspirations. But having gone through multiple legislative changes in my career, past 25 years, I think the lessons of the past must be learned on its introduction. It must be industry ready at launch, because many of us will depend upon it. From previous experience, when SAP 10 was introduced, it had a number of updates, which meant that when trying to give clients the right information to help them understand their specifications to achieve the standards, it could change. And what the industry is asking is that when HEM is introduced, it's certainly fit for purpose. Thank you. That ends my presentation, and we'll now look forward to Q&A.
Excellent. Thank you very much, Jason. And thank you very much to our audience for bearing with us there during our technical difficulties. I'm touching all the wood I've got around me to say that hopefully that is the last of the challenges that we have with technology. But it's time for a bit of Q&A now from the audience. So as I mentioned earlier, if you would like to get any questions in that you have through the Q&A box, I've seen a couple come in already. That'd be really good to get your thoughts on. But I've got a question I'm going to put to you first, Peter, actually, just to get you involved. Let's see, working with Igloo and Blueprint as you do, what are some of the challenges you're seeing around energy and developments that you guys are working on?
Yeah, that's a good question, and I mean, it's one that I would kind of bounce a little bit onto Nigel for his thoughts on a potential answer. I know the challenges are very much um, dealing with reducing the energy cost, carbon emissions, and energy bills, for apartment occupiers, for types of dwelling where that won't and just can't meet the octopus criteria for zero bills, for example. At Igloo, we try and build sustainably in a very broad sense. So that includes a lot of other key outcomes from our footprint process. In particular, health and well-being, more green areas next to homes. We're trying to reduce car use. Certainly, one of the key elements of our master planning process is to try and take cars out of the scheme. If the cars are out of the scheme and parked maybe on the periphery, that means that they can't necessarily be connected to the domestic consumer unit, and therefore can't avail of the very beneficial tariff that Octopus offer for homes that are parked in a garage or in a carport on plot. And with apartments in particular, that's quite pertinent, because often that you just can't connect your car space with a cable through to the domestic consumer unit, and also you can't get the solar that's allocated to an individual apartment anywhere near the level that you need to get a zero bills product. So there needs to be a response to this, because otherwise we're going to have a two-tier market. And I'd also just flag that from a retrofit point of view. And I call this the Lowry territory. The kind of homes that you see in Northern England and, Brackington, Burnley, Blackburn, around Greater Manchester, all of those terraced houses, Coronation Street territory, with little backyards, may not even be big enough for a heat pump, not much roof space for solar, and no on-plot parking. So they can't avail of a lot of the tech that will reduce their energy bills. And so that's it. I'm kind of sort of now directing that over to Nigel, perhaps, for another outlook on that, on what, where solutions might come.
Yeah, and specifically to the apartment point, Nigel, as a nation, we seem to be moving more towards living in apartments and flats than traditional terraced houses as we were back in the day. Is there a route towards zero bills for that type of property, or is it strictly reserved for new builds and of a certain spec?
So we're not exclusive in doing houses, but it is quite hard to get, as Peter said, to get the economics to work on an apartment scheme. That is fundamentally, it's a question of how much energy we can generate to enable us to get to a point where we can generate enough revenue from exports and grid services to offset the costs of import. And on an apartment scheme, when you go above probably 3 stories, you run out of roof space, and often quite a few of the apartment schemes being built have also got roof gardens or other equipment on the roof, taking up space away from potential for solar. So that is challenging. And a challenge. I'll perhaps come back to solutions in a second. I think the other point that Peter raised around challenges was sort of Victorian terrace properties. We have just completed a trial of a Victorian mid-terrace property in London with a small back garden and up and over roof, and we managed to get that to a zero bill spec. So we can do that without doing a deep retrofit. Fitting a high performance heat pump, some basic insulation measures, and then maxing out the solar on the roof. That property was able to work. It won't work in all properties. As soon as you put a dormer window or a room in the roof, you take up the roof space available for solar with those windows. So that also becomes difficult. So there are some existing properties that we'll work on, but there are some properties where you can't get enough solar on to get to a zero bill. What I would say is the benefits of heat pumps, of load shifting, of batteries and smart tariffs can still apply in those homes. But you may not be able to get down to a completely zero bill, but you can make a very significant reduction with those same technologies. And it's the same for apartments. If you can use heat pumps for your hot water through a heat pump cylinder rather than an immersion, you can, again, significantly reduce your demand. And if you can use time of use tariffs to optimize when you're using that energy, you can do that and reduce the cost of energy. In terms of how do we make this work on blocks of flats more broadly, I think the microgrid solution that we're testing as part of a large scale master plan is interesting. That's where we have a single communal battery. Solar is spread across the roofs of the dwellings and potentially adjacent buildings or carports or in a solar farm adjacent to the site. And the net metering, aggregated net metering approach that we can adopt under the new regulations enable us to trial that. The challenge comes in non-domestic supplies. The grid charges are significantly different to domestic supplies, and it becomes a non-domestic arrangement, and that puts a huge amount more risk into the zero bills arrangement. But we do think that is something which would assist in effectively sharing the energy without having to add extra infrastructure into place. But we're exploring that on this first site we've got this year with GS8 and their Thornwood site, and we'll review that in the first homes I've sort of built this summer and see how they're performing and how that setup could be scaled. And on EV charging remotely, that is a challenge. If I charge my car at home, I get it for 7 pence kilowatt hour. If I need to charge it on the motorway, on a Tesla charge, you might get 40 pence, but on most charges, you're paying sort of 70 pence and you're back up to the price of petrol. And if you haven't got a home driveway and you aren't able to get a charger to where you parked your car back to your home electricity supply, you have to go to a public charging point, and that is still much more expensive. So that is a challenge. The final thing I'd say on that is the cost of electricity in the UK is artificially high due to market setup and the way the market is structured. In other countries, the Nordics, other parts of the world, the cost of electricity is similar to the price of gas. And that would make electrification of heat through heat pumps or electrification of EV charging or electric bike charging much more cost effective in the future. So that is something we're waiting to hear this year from government, the response to the electricity market reforms. And we've been advocating strongly for some significant reforms that would make massive reductions to electricity costs for people across the country. And that's broadly what we need to make us less reliant on gas. And gas sets the price for both gas for heating, but also for electricity at the moment. That is one of the reasons the prices are going up, as it was announced this morning, is because the gas price has gone up, and that drives both up electricity and gas at the moment because gas is used to set the electricity price.
Yeah, it's interesting you mentioned that obviously the hikes that have been announced this morning and the increase of the energy cap. I mean, do we see that as increasing potential house builder interest in products like Octopus Energy and similar products?
Yeah, I think we launched the product towards the end of 2022 and the start of 2023 when bills were extremely high. I think one of the interesting points that's come up from customers who've moved into the zero bills homes is taking away the stress and worry and anxiety of bills going up and what that means for their budgets. So the zero bills has got a fair use allowance. So if you go berserk with your energy use, you would pay for the energy beyond that level. But it's set at double typical consumption. So you've got to go pretty far to get a bill. And in fact, the customers so far haven't had a bill. So that does make a big difference to the sort of stress and anxiety around that. So clearly there is a commercial case around how much money you're saving, which also means you potentially borrow more money through your mortgage with some of the mortgage lenders we're working with. But also what's the value uplift in property value you're going to get from not having to retrofit your home because it already has the equipment installed, and what's the value you place on not having to stress and worry about bills. So one of the case studies had an interesting demographic shift in people interested. So they had people who were downsizing retiring, wanting to have no mortgage, no bills. And certainly in the build to rent sector, having bills included in a new build single family home is also quite an attractive proposition. So there are some interesting points there.
Brilliant stuff. We'll put the next question over to Jason and to Peter as well, actually, because it's a project that I know Peter's very familiar with. Is there a missed opportunity for Future Home Standard to consider community energy generation and storage, or have examples such as Trent Basin showing this to be a challenge and potentially unviable?
Well, yeah, I'll come on to that because the Trent Basin and Jason may want to chip in. The issue at Trent Basin with the community energy project there is the point that Nigel's already made. And this is that the non-domestic grid connection costs are significantly higher than a domestic connection cost. So the community energy project at Trent Basin ended up, after the impact of the war, has not been viable, because the buy-sell arbitrage was ended up being wiped out by grid connection charges. So just to explain the buy-sell arbitrage, you have a big battery, you buy your energy based upon Nigel's graph of energy cost when it's negative, and you flog it back to the grid when the cost is very high. But that was all wiped out by the non-domestic grid connection charges. So the problem with the battery at Trent Basin, it wasn't what I would call a neither now in the summer. It wasn't big enough to make a margin on that, and whereas the small domestic battery is fine because you're connected to the grid through a domestic grid connection cost, which is much lower. So the battery at a domestic scale works very well for the zero bills, but this kind of medium-sized, community battery didn't financially, but a much bigger one does. So it was kind of caught in the middle, and that's the main issue, is that non-domestic grid connection cost.
Yeah, I mean, aside from that, I think we're yet to see the final version in terms of what the software will look like. And I think the greater accuracy that's going to be in the software to be able to analyze how the home performs is going to be useful in terms of making financial decisions or investments potentially in criminal battery scenarios. More confident than we ever did in the past. So I wouldn't dismiss it. I wouldn't dismiss that it's going to be either a missed opportunity. I think there are still opportunities within everything I said about the products database and the ability to develop and to drive innovation, that if it has merit, it'll be introduced.
It's certainly an interesting juncture there for that. We'll see how that goes with the.
Just to finish up on, just following up on what Nigel said, I think the microgrid is very interesting, as provided you can get the sufficient solar connected to it, and that's where we need to be more creative in, the parking courts, need to be covered with a solar pergola, and that feeds the microgrid battery, and everybody in the scheme then benefits with their different time of use of energy. Some people working from home, other people not working from home. Different energy use profiles within the apartment block, for example, would enable all of those benefits to be passed on to the consumer.
Excellent. Well, we'll wrap up with a question from Ashley Cowdrey. It's coming for Nigel. So Ashley said that domestic hot water generation is often the highest regulated energy use in a home. Heat pumps struggle with those higher temperatures without being expensive. So phase change storage heaters on direct electricity, such as SunAmp units, can only charge during low usage grid periods. So Nigel, do you see that as a viable solution sort of moving forward?
So I would challenge the question on heat pumps struggling with higher temperatures. The latest propane R290 heat pumps perform very well at high temperatures, and I'd suggest those that aren't familiar with, there's a website called heatpumpmonitor.org. Have a look on there. You'll see some of the best performing heat pumps in the country, and that shows that for hot water they're achieving annual coefficients of performance of 3 to 4, and sometimes more than 4 for hot water, as well as 4 to 5 for heating on both air source and ground source. So heat pumps are able to perform very well. They're often not very well commissioned, or installed to perform as well as they could do. And so the new refrigerants in modern heat pumps have lower global warming potential and perform better at high temperatures. So if you can get 3 to 4 units of heat and you've got a storage medium for 1 unit of electricity, that is, and you can still charge in the same nighttime periods, you get 3 or 4 times the benefit. And so, yes, if you can fit a heat pump and you can use that to run that efficiently, that would, I think, be still better. If you're not able to for whatever reason, or you've got an existing system that's running on immersions, on direct electrical heating, it does make sense to shift those loads. And we've recently introduced our snug tariff. So we've got a cozy tariff for heat pumps and a snug tariff for electric storage heaters and immersion heaters that are radio controlled. In June, the BBC will be turning off that radio control network, and unless you've upgraded your meter to a smart meter, that you'll lose control of that heating system and get to very high costs. So this is quite a pertinent point actually right now. For the next few months, we are rapidly trying to get in touch with and switch out those old radio control meters to the new ones, and that enables people with storage heaters, whether it be phase change or not, and direct electrical systems to benefit from low costs at night, but as well as low costs in the early afternoon, which has always been a problem with the standard economy 7. You've got very cold, unpleasant environments in the evening when the house is cooled down, and then getting very hot through the night when you're trying to sleep. So that tries to tackle that issue better with that snug tariff. So the principles definitely apply. I'm still an advocate for heat pumps being 3 or 4 times as efficient as even in winter, and even delivering hot water.
Tom, I'll just add a little bit more to what Nigel said there, looking at what Ash's questions. I think, from experience in SAP, products akin to what the questions state there are not well recognized in there, and they don't get traction in the software at this moment in time for that reason. I'm sad to say, but if somebody says they're going to fit a new technology, we often ask, is it in the SAP database? Which is one of the reasons why my presentation talked about the database in reasonable level of detail. That is going to change, and that is going to change for that exact reason. So I think to answer Ash's question, there's the part that Nigel answered, but also I would see greater traction for these technologies within the regulatory software performing better than they've ever done before because of the 30-minute time step. So it will be a viable solution for regulatory purposes, certainly going forward, I'd say.
Excellent. Well, thank you very much for that finish, Jason, and thank you to yourself, Nigel and Peter, for your time today, and also your adaptability and flexibility when things didn't quite go the way they were supposed to on the technology side of things. And thank you very much to you guys in the audience as well for your patience in dealing with the technical challenges that we had at this. And hopefully you found today's webinar really useful and helpful, and lots of information in there for you. You can find out more about ProCon Nottinghamshire and Leicestershire on their respective websites. Plenty of events coming up from both organisations in the coming months. But the last thing to say is enjoy the rest of your afternoon, and thank you very much for your time.